All right, so number 5. The domain. Okay. Domain always refers to x values. Okay, domain is x values. So the domain to any polynomial function is all real numbers. Okay, that's the symbol for it. You can write it out however you want to express it. I think the symbol is the easiest thing to use. It looks like a T and an R connected, or I call it an R with an extra back on it. However you want to look at it, the domain is always all real numbers. Here's why. Okay, here's why. I can plug any number I want to. Positive, negative, decimal, fraction, doesn't matter. I can plug in any number. I can raise it to the 4th power. I'm going to get an answer. I can square it. I'm going to get an answer. I can multiply by 3. I'm going to get an answer. I can add and subtract all those numbers together. I'm still going to get an answer. Okay, numbers are excluded from a domain if when you plug it in, you don't get an answer. We're going to look at some functions later on this semester where there are certain numbers that we can't plug in because we won't get an answer. But that doesn't happen with a polynomial function. These are polynomials, okay? All polynomial functions have a domain of all real numbers. Okay, y-intercept. What's the y-intercept? Y'all looking at the graph, where does it cross the y-axis? Number 5, where does it cross the y-axis? At 2. Okay, at 2. Now, y-intercept is a point. You need to write it as a point. It's the y-intercept, so the 2 is the y-coordinate. The x-coordinate is 0. Notice it's also the constant on the end. If you look at all these, look at number 1. Number 1, we can't see where it crosses the y-axis because it goes off the graph. Number 2, where does it cross the y-axis? At 0. Guess what? There's not a constant on the end of number 2. Number 3, it crosses at 2. It has a constant of 2 on the end. Number 4, crosses at negative 3. It has a constant of negative 3 on the end. So that constant number on the end is always your y-intercept. But you can always look at the graph too. Okay, x-intercepts. It looks like, looking at the graph, it looks like one of them might be 2, but it's kind of hard to tell. So let's go through the process of finding x-intercepts again. Everybody needs to have number 5 plugged into their calculator. I know I'm doing it, but you need to do it as well because you need to know how to find these things. Okay, number 5, negative x to the 4th plus 3x squared plus 2x plus 2. Graph it. Okay, let's find, how do we find x-intercepts? Second, trace, which option? Number 2. Okay, it is not number 5. Number 5 says intersect, not intercept. Okay, number 5 is something different. We're looking for option number 2, the 0. Okay, zeros, x-intercepts, solutions, roots. Those all mean the same thing, and I will keep repeating that over and over and over again until we remember it. Okay, so left bound, we need to move our cursor. In this case, the left bound is below the x-axis. Press enter. Right bound, we need to move it above the x-axis. And for the guess, you don't have to move it, just press enter again. So, we do not have nice, pretty whole numbers for our 0. Negative 1.592. I always round to 3 numbers after the decimal. 3 numbers is a good cutoff there. 59, that 5 rounds the 1 up to 2. Okay, and it's a point as well. It's the x-intercept, so the number goes for the x part, and the y is always 0. Now, there's another one. That's not the only one. We got to go find the other one. So we need to move our cursor over. This time the left bound is above the x-axis. The left bound is above the x-axis. The right bound is below the x-axis. Okay? And this 0, or x-intercept, is 2.099. Now notice, I don't know if your calculator did this, but mine did. The y doesn't say 0. Okay, the y does not say 0. But look at what it does say. Remember, I told you this e with the negative 12, that's scientific notation. That's times 10 to the negative 12th. That means we're putting 11 zeros in front of 1.2 and moving the decimal. That's 0. Okay, you can see the cursor is sitting on the x-axis. Okay, it's really 0. It's just, it has approximated it, and it didn't approximate it at exactly 0. But it is 0. Okay, I promise it's 0. Okay, so let's look, let's keep going. Let's find the extrema. Okay, let's find the extrema. We have how many maximums on this one? How many maximums? 2. How many minimums? 1. We have 2 maximums to find and 1 minimum to find. So let's find, let's start with the maximum. Okay, second trace, maximum is number 4. All right, my cursor is closest to the one on the right, so I'm going to start with that one. Left bound, right bound, press enter. Okay, here's our maximum. Very rarely are these going to be nice, pretty whole numbers. So maximum is 1.366, 6.848. You do have to include both values. You need the x and the y. All right, let's find, I'm moving right to left here, so I'm going to go for the minimum next. Press enter, right bound. Okay, we have a minimum at negative 0.366, 1.652. And we've got another maximum. So find left bound, right bound. It is important, you don't have to move your cursor to the exact same places where I was moving them, but it is important to get them in the right place, because it will calculate a maximum or a minimum regardless of whether you actually have the maximum or minimum between your 2 points. Okay, now let me say something about this one. Just write down -1 for that. Negative 0.99999, that's -1. Okay, that many nines, it's -1. Okay, so -1, 2 is our other maximum. Now, we need to talk about a little bit of terminology here. Since we have 2 maximums, this one right here, the first one that we found, is what we call the absolute maximum, because that is the highest point that our graph will reach. Right over here on the right side, that point, 1.366 and 6.848, that is the highest point that this graph reaches. So that's called our absolute maximum. -1, 2 is just what we call a local maximum. And our minimum is also just what we call a local minimum, because even though we only have one of them, because the ends of our function are falling, they're decreasing, we hit lower y values than 1.652. We have negative y values there. 1.652 is not the lowest minimum value that we hit, so that's called a local minimum as well. Okay, questions about the extreme? Okay, so speaking of y values and absolute maximums and minimums and stuff, let's talk about the range. Okay, the range, if domain is talking about the x values, range is talking about your y values. Okay, I just told you that that maximum on the right side is what we call an absolute maximum. That's the highest y value that our graph will achieve. So that means that our range of y values, all the other y values, are less than or equal to that y value of 6.848. Okay? That is the absolute maximum that we're going to hit right up here. All our other y values are below that. Y values are less than that maximum number. Okay? So, for example, let's just look at number 6. Glance over at the graph of number 6. That one has, does it have an absolute maximum or an absolute minimum? Number 6. Absolute maximum or absolute minimum? Minimum. It has an absolute minimum. It has a lowest point that that graph hits. So its range will be y is greater than or equal to, because all your y values are higher than that absolute minimum value right there. Okay? All right. Last characteristic that we need to talk about is our end behavior. Okay, what are the ends of our function doing here? Okay, we're still going back to number 5. I hate to keep changing gears on you so much, but I just wanted to point that out, comparing 5 to 6, maximum versus minimum. Let's talk about the end behavior. The left side, as x approaches negative infinity, what are our y values doing on the left side? What are the y values doing on the left side of number 5? They're decreasing. They're going to negative infinity. On the right side, as our x values are going to positive infinity, okay, that's always the right side. The x part doesn't change. The left side is always x approaches negative infinity. The right side is always x approaches positive infinity. Okay? What are the y values doing on the right side? Somebody different. What are the y values doing on the right side of number 5? Y'all see it? You told me before. Say it louder. Decreasing. So they are going to negative infinity. Okay, I like you to know both of those terms. The decreasing and increasing makes more sense visually. It's what you're watching them do, but this is the notation that you will see on the final exam. You will see this infinity notation, so you got to get used to that. So like I said, the x part always stays the same. Okay, the left side is always x approaches negative infinity. Okay, left, negative, right, x approaches positive infinity, right side positive. Then you're looking at the graph to see what the y values are doing. Okay, so here's what I need you